Okay, let's have a look. On the screen, I've got our first question. It says, in the diagram, NPQR is a cyclic quad. Now, having got that as a cyclic quad immediately, I can say that there are angles that are equal. I'm going to say that this fat angle over there is subtended by RQ. It's equal to P2 over there. This angle at R1, small angle, is subtended by NP, and NP also subtends angle Q2 over here. Then here we have P1, so let's use that symbol. And here we have Q1. Remember for your exams, folks, to take in different colored pens. Okay, just a red, no, don't use a red. Maybe use a green, a blue, a Koki pen, an orange and a pink, light blue, whatever colors you can have to do your geometry with, so that you can do what I do on the screen at the moment. Okay, so we've read that all of this is a cyclic quad. They've also told us that RNS, which is RNS, now I numbered it as N1, is equal to PNQ, which is N3 in my case here, and they're both equal to X. Okay, so I have that this angle here, I'm going to change color, is equal to that angle over there. When I use another color, I don't have to use different symbols, folks. That's what's so nice about this. Okay, then in that same breath, we can say that BQ subtends angle N3 and R2. So PQ, the angle here at R2 is also an X. Let me put it in there for us. So far we've got 3 X's on our diagram. That's quite nice. Okay, I think we've exhausted all the theorems that deals with a cyclic quad. Let's read on. S is a point on chord PR. Now, folks, they're telling you here, this is very important. This information is not just there for the fun of it. They are, by saying that, they're telling you that that line, PR, is indeed straight, folks. It's a straight line. Why is that important? Well, you cannot say that you just imagine this is a line of some sorts and this is another line. I cannot say that this angle here is equal to that one unless I have read that those two angles are formed by intersecting lines, because the one line could look like that. Okay, and your eye doesn't get it. So you have to read that things are straight. The second thing that everybody always forgets is if there's something straight and it crosses across the diagram, then there might be an external angle somewhere along that line that we're going to need later on. Okay, let's see what they ask us. The first thing is to prove that triangle NSR. Now let's just do ourselves a favor and let's highlight that. I want to show that angle NSR, which is this one over here, is indeed similar to triangle NPQ. Now that is that triangle that lies here on the one side of our diagram. Okay, so we must prove them similar. Now folks, if you throw your eye across it, it is similar already. Look at this. At this point here, let me just get my pen back. At this point we have an X, at that angle we have an X. In fact, that was given. This angle is equal to this one, so the third angle will equal the third. So that's quite an easy one. Let's do the first one over here. In triangle NSR and triangle NPQ, always remember, you've got to tell the person who reads your work the triangles you're working in. So in NSR, this one, N1, is equal to N3, and they're both equal X, and folks, that was just given to us. That was this information up there. Then we said that angle R1 is equal to angle Q2. The reason, angles in the same segment. Okay, and based on that, if you've got two of the three angles equal, the third angle on a planar triangle will automatically be equal because they can only add up to 180. So we can conclude here that triangle NSR is indeed similar to triangle NPQ, and our reason being angle, angle, angle. There's our first 3 marks. Okay, so that is what we have for the first question. Let's look at the second one. The second one says triangle NQR. Now, NQR is the big one. Okay, let me see if I can delete that green part. Yes. Let me actually use my mouse here. It's going to go quicker for us. If I now tell the computer to quickly delete those for me, and this third one that I've got up there, then I can highlight my new triangle that I'm going to work in. Okay, let's get rid of that side. We right-click and we tell it to go away. Okay, off it is. Okay, so let us select our highlighter again, and I'm going to use green again for this case. NQR. Now, NQR is this big triangle that lies over here. Let me just get my highlighter to give me some. There we go. Okay, so NQR. Let me just get rid of that. Sorry, folks. NQR, let's use the blue. It wants the blue. N, R, and Q. That's our one triangle. And we must prove that this is similar to NPS. Now, NPS is the one that lies here on the inside. I'm going to make it with dotted lines because they overlap. So we might not be able to see it so nicely. Now, just cast your eye across those two triangles. If you look carefully across those two triangles, we've got a 2-liner at P, and we have a 2-liner at Q1. Those two are equal because of angles in the same segment. Okay, so all we need to do now is find one more angle that is equal to another one, then the third one will definitely be equal. So in triangle NQR and triangle NPS, the following is true. I hope that this is helping you, Mandla. The first thing we have is Q1 is equal to P1. Okay, so Q1 here was equal to P1 over there, and that was angles in same segment. Now, I'm going to cut into this angle over there. If you look carefully, that angle there consists, so N1 plus N2, let me write that down. It belongs to this triangle. N1 plus N2, I've got here, is got to be equal. It has to be equal to N1, N2 plus N3. So let me just change the 1 to a 3. Is equal to N1 plus N2. Now, folks, let's see why. Here's an X plus a dot to make up this angle in the bigger one. Then in that triangle, I've also got an X plus a dot. So because both those angles were equal to X, and I'm adding the same angle to form the full angle, I can say that those two are indeed the same. Okay, so my reason would be N1 and N3. N1, N3 is equal to X. And what am I doing? I'm adding the same amount to N1 and N3. So I've shown that those two triangles are indeed similar. So let's conclude that. Triangle NQR is therefore similar to triangle NPS. And the reason again, angle, angle, angle. Okay, so it seems like the first two are fine. and easy to get to. We had to pull a little bit of a trick in that second one, but it wasn't a difficult trick that we pulled there. It was literally just seeing that we're adding equal quantities. Now, for the big part of this question, it says, show that for how many marks? For 4 marks. Number 3, we've got to show the following. Now, let me write the show in blue so we know, and make sure we know what we're doing. NR times PQ plus NP times QR. We've got to show that that is equal to NQ times PR. Yeah. Now, folks, you've got to ask yourself, how did the examiner get to that? It's not difficult. You've just got to decipher what is written there. You've got to take one ratio and you've got to add another ratio to it. So let's search for those ratios. I want NR and PQ. Well, in my first one, there's NR and there's PQ. I also want NP and QR. So I also want NP, which is this one here, and QR. So maybe the NP and the QR comes from this triangle over here. Let me use the bottom here, NP and QR over there. So I'm going to start anywhere and pull those ratios out of my similar triangle. So let us call this set number 1 and set number 2. So from set number 1, I'm going to, let me just get my pen, I'm going to start working with a ratio. From set 1, I'm going to choose PQ. Now, if we look for where is PQ over NQ equals SR over NR. Okay, so I'm looking for what I've got over here. Okay, so my first one that I can pull off is NR over NS. NR over NS is NQ over NP. NR over NS is equal to, look again, NR is outside over the first 2, will equal outside on the other side over the first 2, which is NP. Now, the reason shortly is sides are in proportion. Okay, so I've got that first ratio from there. I can then also go and find a ratio for PQ, which is over there. That's our PQ over here. Now, if I use PQ, I am supposed to use SR. So let me use another color. PQ and SR is what I want. And for the other side, I'm going to use NR and NS. Okay, so let us go for NR over there. I've already got NR, I don't have NR. So what can I do? I can say NR over NS is NQ over NP. Okay, so NR, let me just write this down. NR over NS is equal to, so NR is the outer over the first 2 is the outer NQ over the first 2, which is NP. Let me just see if I did this one correct. I did NR over NQ. Okay, so NR over NQ on this side would be NQ. There's a mistake here. NQ over NP. NQ over NP I've used over here. So I had to use NR over NS over there. So let me just remove that because we've now got the right version over there. Okay. Folks, this is always very, very difficult for you to work with something that you've got to decipher. And the same here is still in place. The fact that the sides are in proportion. Okay, so let's see, what do I have so far? Do I have NR times NP over here? Do I have NS times NQ over here? Okay, so I'm going to look for all of this in those products. I can also go to my second one, and I can say that NQ, the first one, over the last two is equal to the first two over the last two. So the first two is NQ over QR is equal to NP over PS. And again, the sides are in proportion. Now let's see, NQ and PS, do I have QR and NP? Ah, there's that combination. So immediately from here, I can conclude that I've got the one, I'm going to write it in green, that QR multiplied by NP, which is this one, is equal to NQ times PS. That is as a direct result from this working over here. I still do not have my PQ in my picture. Okay, so let me go and see where PQ lies. PQ lies there at the top. Let me just erase some of this if I'm not going to mess it up. Let me just erase that, erase this one, and erase this one. Okay, so we're going back to that, and we want what? We want PQ and NQ. So we want PQ over here, and we want NQ over there. So first, the last two over the first and last. I'm going to write it down here in yellow. So it's another proportion that we can find then. That is that PQ over, so last two over first and last, NQ, is equal to the last two over first and last. So equals QR over, what is that, NR. Okay, so let's go back and let's see, do we have? We have this one if we use this ratio over there. So from that, we can say that PQ times NR, which is what I want, PQ times NR is equal to NQ times QR. Okay, now the proof comes in the pudding. Let's see, what do we get here? If I now take these two, I take this one, PQ times NR, and I add to it NP times QR. That's after all what they asked me to do. Okay, what do I get that to be? I get that sum to be NQ times SR plus my NQ times PS. Okay, so I've got my two, I just substituted them with the ratios that I worked with, and now you can see what is happening that's interesting on the right-hand side. The NQ is common. Okay, if I remove NQ, I get SR plus PS. Now, if I go to my diagram, SR plus PS is nothing else but PR. So this whole side there, I can substitute with a PR. And that is what they wanted me to prove.